Bucka. Ha. You know the deal.
So what we're going to look at next with solving equations is equations where we have variables on both sides of the equal sign. Now, just like with any of the previous examples, our goal is to isolate x, get x by itself on one side of the equal sign. So the first thing we have to do here is get all the x terms on one side and all the number terms on the other side of the equal sign. As we saw with the previous examples, we can move whole terms across the equal sign. So I want to bring this minus 2 over to the right hand side of the equal sign, and I want to bring this x over to the left hand side of the equal sign. This way we've got all our x terms on one side and all of our number terms on the other. So let's start with that x. Now, of course, we still have 5x on the left hand side. That's not changing at all, but we're bringing this x over to the left hand side. So you have to ask yourself, well, what sign is x? There's no sign here in front of x, so we assume it's a positive. So if I move it over to the left hand side, it has to become minus. Now similarly, when we bring this minus 2 over to the other side, that's going to change as well. But first we have to ask ourselves, well, what do we still have on the right hand side? We still have this positive 6, so we have to write that as positive 6. If we bring that minus 2 over to the other side of the equal sign, it of course changes signs. It becomes plus 2. Now we've got a case where we can simplify. 5x minus x, those are like terms. X is the same as 1x, so if we have 5x and we take away 1x, that simplifies to 4x. And positive 6 plus 2 is 8. We're not quite done because we still have to isolate the variable. So what do we have to get rid of here? We have to get rid of times 4. To get rid of times 4, we divide by 4. If I divide one side by 4, I have to divide the other side by 4. These cancel out, make 1x. 1x is the same as x, and 8 divided by 4 is 2. We can check to see if this is the right answer by once again substituting it back into the original equation. So if I start with our original equation, which is 5x minus 2 equals x plus 6. And remember, an equal sign, another way to say equals is the same as. So we're saying 5x minus 2 is the same as x plus 6. So if I substitute that value in for x, we found that x was equal to 2. So I just rewrite the equation, but instead of writing an x, I write a 2. Of course, we have to follow order of operations here, so 5 times 2 is 10. I could probably go ahead and simplify the right-hand side if I want. 2 plus 6 is 8, and then 10 minus 2 is 8, and on the right-hand side, we also have 8. So we've got a case here where the left side does equal the right side, so the left side is the same as the right side. So in fact, this is the same as this, so we can assume that our answer for x was correct. So here's another example where once again we're being asked to solve this algebraic equation. So our goal is to isolate the variable on one side of the equal sign. And again, it doesn't matter what side of the equal sign we isolate the variable on. It could be the left side or the right side. So just like with the previous example, the first thing we want to do here is get all the x's on one side and all the numbers on the other side. So let's say we want to move all the numbers to the right hand side. So that means I'm going to bring this 5 over to the right hand side of the equal sign, and I want to get all our variables to the left hand side, so I'm going to bring this x over to the left hand side. Now here's where we have to be very careful with our operations. What we're doing to 3x is we're subtracting 3x to here. Since we're bringing that 5 over to the other side, what we're left with on the left hand side is still minus 3x. I'm bringing this x over to the left hand side. It's a positive. If I bring it over to the left hand side, it becomes a minus. Similarly on the right hand side, well, if I get rid of that x on the right hand side, what we're left with is minus 15. I brought that 5 over to the other side, so it has to become minus 5. It was positive 5 on the left hand side. It becomes minus 5 on the right hand side. Well, now we can simplify. Negative 3x minus 1x is minus 4x. If I subtract 3 and then subtract 1, altogether I'm subtracting 4. Minus 15 minus 5 means I'm subtracting 15 and then subtracting 5. Altogether, we're subtracting 20. So now we have a case where we can go ahead and isolate the variable by doing the opposite of what's there. The opposite of times -4 is divide by -4. If I divide one side by -4, I have to divide the other side by -4. These cancel each other out. We're just left with x, and -20 divided by -4 is 5. Okay, now that we've taken a look at a couple of these examples, you go ahead and try too. So what I'm going to ask you to do here is pause the video and go ahead and solve each one of these equations. And when you've got your full solution, where you've got all the x's on one side and all the numbers on the other side, and then you've gone about your simplifying and isolating the variable, go ahead and press play to see the full solution. Okay, so taking a look at the first one, hopefully the first thing you realized was you have to get all the x's on one side and all the numbers on the other side. So we're going to take this -2, bring it over to the right hand side, take this 4x and bring it over to the left hand side. So when we do that, well, on the left hand side we had 3x, we still have that 3x. We're bringing 4x to the left hand side of the equal sign, so it has to become -4x. On the right hand side we had -5, so we still have that -5. We brought -2 over to the other side, so it becomes +2. Now we've got a case where we can simplify. 3x minus 4x is -1x, which I could write as just -x. -5 plus 2 is -3. Now a lot of students will look at this and say, well, I'm done. I've isolated x. Unfortunately, we're not quite done yet. I still have that negative sign in front of that x. Well, -x is the same as -1x. So what we still have to get rid of here is times -1. To get rid of times -1, we divide by -1. So of course that's what we have to do to the right hand side as well. Multiplying by -1 and dividing by -1 cancel themselves out. -3 divided by -1 is +3. If we take a look at the next question, again, our goal here is to isolate the variable on one side of the equal sign. Probably the first thing you want to do here is bring this +x over to the other side. When you do that, what you have is 5x plus 3x, and then you brought +x over to the left-hand side, so it becomes -x. And then what we have remaining on the right-hand side is 7. Well, now we go ahead and simplify the left-hand side. 5x plus 3x is 8x. 8x minus x, or -1x, is 7x. We still have 7 on the right-hand side. Now we've got a case where we can go ahead and isolate the variable by doing the opposite of what's there. The opposite of times 7 is divided by 7. If I divide one side by 7, I have to divide the other side by 7. Those cancel each other out, and our answer is x equals 1. If those were the solutions that you got to these two questions, congratulations, you now have a firm understanding of how to deal with equations where you have variables on both sides of the equations.